Alrighty, hello everyone, my name is Kit, and in this video, I'll be talking about alignment in Korge. So how to align various containers and views against one another. So to start, let's just go ahead and create some solid rectangles. Let's do this 100 by 100, color equals colors dot, let's do yellow. And then for the second one, we can do solid rect 50 50, and then for this, let's make this color red. Alright, so when we go ahead and run it, we get this, which is what we're expecting. So both of these rectangles are drawn at the position 0 0, which is this top left part here. Notice that if I full screen, 0 0 is actually still here because there's some bordering that goes on. If you want to disable that bordering, you can do clip borders equals false like this. But for now, we're just going to leave it as is. Alright, so yeah, both of these rectangles are being drawn at 0 0. And I think Korge follows something called the painter's algorithm, which means that each element is drawn one after the other. So first, the yellow rectangle is drawn, then afterwards, the second rectangle is drawn. So this is by the order in which they are instantiated. You'll notice if I go ahead and flip this ordering around, then the yellow rectangle will just basically overlap with the red one, so then you can't even see the red one. Alright, so let's go back to our scheduled programming. So alignment. So first I'm going to center this on the stage. So I'm going to center the first rectangle on the stage. Then you'll see that it's in the middle of this rectangle here. So let's say that we want this red rectangle to be in the top left corner here, this section. How would we do that? Well, the way that we can do it in Korge is using Korge's built-in alignment methods. So you can find these methods by going on any container and then doing .align and then looking at the autocomplete here. So we have a bunch of different methods that we can use. So the first thing that we need to do is align the right side of this current rectangle to the left side of the first rectangle. So if we go ahead and do this, then this is what we get. So we assign the left side of the red rectangle to the right side of the red rectangle to the left side here of the yellow rectangle. Right, so next we want to align the top of this red rectangle to the top of the other rectangle. So if we go ahead and run this, then yeah, what we get is this alignment, which is what we want. Right, so yeah, some other stuff that you can do is add some padding. So we wanted to pad this right side here so that there's 10 pixels between these rectangles. Then we can do that by adding some padding. So this is padding, and then we do 10. Right, so it's going to pad 10 pixels from the left here. Okay, so say that we want to do some other stuff, like for example, center the rectangle on various different places. There's also like various methods for centering. So just do .center, and then you'll see these different methods here. Center X will center the X. The X on whatever container that you want to center it on. So if we do center X on rect 1, and let's go ahead and just run it. Then it centers the x-axis, so the x-axis parts on the middle here of this rectangle. And we can also center the y, so center y on rect 1. And what we end up doing is just centering on that rectangle itself. But there is an even faster way to do it, or a way that involves less line, which is just center on. So center on will center on both the X and the Y, so we don't need this anymore. So we just go ahead and run it, then it will just center it like so. And notice that the centering basically overrode any previous alignment. So it overrode these two alignments here. So just something to note. Now, an interesting thing is that if we actually move the first rectangle around, position 100 by 100, then you see that the yellow rectangle moved, but the red rectangle didn't really move at all. So if we want these two to be grouped up together and to move together, how would we do that? Well, a way that you can do it is by using something called a container. So this dot container, and then we can move these two rectangles inside of this container. And then we'll have the centering on as well. So let's just go ahead and do this. I'll give it a name, rect container. So if we go ahead and run it, then you'll see that these two containers, this container is basically like contains both of these children views. So if we go ahead and move the rect container itself, then you should see that both of the children will be moved as well. So we do 100 by 100. Then you see that the positional movement was propagated to the children. So what actually happened was that it went through each of the children that are stored in the container, and it did a 100, and it basically told the children to move by an X delta of 100 and a Y delta of 100. So in the end, we get this to be moved over here. So both of these elements got moved together. Now something that's very interesting is that if you do rect 1.center on stage, so if we centered it first before we put into this container here, you see that the container itself, you see that when we did the 100 by 100 position, it didn't actually move it to the top here because the 0 point is right here. So we would expect that the container or all the elements within would be moved to this 100 by 100 spot. But that is wrong. That is not the right way of thinking about containers. The way that you should think about it is that when you do a positional realignment or whatever you call it, you're basically applying the delta of that positional movement to the children. So that's why you see here it moved 100 by 100 from where it was originally at. So previously the rectangles were here. Since it moved 100 by 100, meant it added 100 delta and then added 100 delta to the Y. That's why it moved to this spot right here. And if you look at the children, or if you look at the implementation of the container, you see that it stores the views as children. So yeah, don't think of the container itself as some kind of object with its own boundaries, because it doesn't. All it does is it propagates all of these various movements to the children. So this can get quite confusing, so I don't recommend you doing any centering on the stage within where you create the container itself. Usually I like to make it so that the container itself corresponds to the maximum width and height of whatever rectangles or objects are inside. So usually I will have one main rectangle, and then I'll have everything else overlapping inside of that main rectangle. So yeah, if we run it like this, then 100 by 100, it makes it appear like we're moving that whole entire container 100 by 100. So this is just a much better way of thinking about it. Don't I definitely don't recommend you do like any like center on stage when you are creating the rectangles inside of this container lambda here. All right. Is there anything else? Oh yeah, something else that you can do is add padding. So, oh wait, did I already talk? I'm not sure if I talked about that, but if you wanted to add padding, then if we do rect2 dot align, just do our alignment again. Top of rect1, rect2 dot align right to left of rect1. Let's go ahead and run this. Oh wait, what? Rect. Oh yeah, I need to align this center on stage, because since we're at the top left position, if we align it to the left side of that rectangle, then it just basically doesn't show up because we're out of bounds. All right, cool. So if we wanted to add some padding to the right side here, then a way that we can do that is by using the padding parameter that's provided here. So if we do 10, then you see that it adds 10 pixels of padding right here. Cool. So hopefully this tutorial has helped. So just remember, there are various methods that you can use. So the center methods and then the align methods. Then if you want to group stuff together, use a container, this dot container. All right. Hopefully this helps. Thanks for watching. Bye.